Hi, College Algebra. This is section 2.4. We're going to be talking about linear functions, and the next section is also going to be about linear functions, but here today we're going to be looking at graphing linear functions and the linear function in standard form, how to find a slope and the average rate of change, and look at a linear model. Alright, here is what a linear function looks like. It is of this form right here, ax plus b, or if you remember from your algebra class you took before, it was mx plus b, and we'll take a look at that form too. And the domain and range for any linear function is going to be negative infinity to infinity. First thing that we're asked to do in this example is graph this function, the 3/2 x plus 6, and give the domain and range. And how we're going to do this is how this thing states up here. It says graph a linear function using intercepts. So we're going to find the x-intercept and the y-intercept. And this is how we do that. For x-intercepts, and for y, alright, so we take our function, and instead of f of x, I'm going to replace it with a y. Okay. Same goes over here. And then for your x-intercept, what you want to do is solve for x. And you solve for x by plugging 0 in for y, because whenever you have an intercept on the x-axis, your y value is 0. And then kind of a similar situation for the y-intercept. You want to solve for y when your x is 0. So plug in 0 for your x value, and then solve for y. Okay, so here, solving for your x value, for the x-intercept, I'm going to say let's subtract negative 3/2 x from both sides to get that. And then my x ends up equaling negative 4. And that is just because I ended up multiplying both sides by the reciprocal of this fraction here. And we end up getting 6 times negative 2/3, which reduces to negative 2 times 2, or 2 times negative 2. Which is that. So that is our x-intercept, and our y-intercept, well, this right here is going to be 0. So our y-intercept is actually pretty easy to find. It's just 6. So what this means is we're going to plot the points negative 4, 0, because our y value is 0 for an x-intercept, and then 0, 6, because for a y-intercept, our x value is 0. And there we go. Plot those points. And that's what I have on the next slide. That's what we're going to do. Okay, so see here I have negative 4, 0, and 6, 0, just like we found on the previous page. And what we're going to do is plot these points and then join them with a straight line. So here is negative 4, 0, and 0, 6. Now join them together with a straight line. And then on the previous slide it said to also find the domain and range. Well, remember, like I said, the domain and range for any linear function is going to be all real numbers, or in interval notation, that is negative infinity to infinity. And that's all I'm going to put here. Okay, there we have it. Let's look at something else. All right, so in example 2, we're asked to graph f of x equals 2, and then give the domain and range of this function. Well, since f of x is always going to equal 2, that means we are not going to have an x-intercept, and this line is going to be a horizontal line that just happens to be at y equals 2. So here, I'm going to change colors. Here is the graph of f of x equals 2. So it's just a horizontal line at your y-intercept of 2. And for this one, the domain is going to be, again, remember, domain is all of your possible x values. Well, this line right here covers the whole domain of the x-axis. So again, from negative infinity to infinity is what this domain is going to be. And then the range, remember, it's all the y values. Well, the only y value on this graph is 2. So it's not covering the whole y-axis like it is covering the whole x-axis. The only point that it covers is at 2. So how we're going to state this is put it in a set. Sorry. Just like that. Okay? And we are done with domain and range and graphing f of x equals 2. So remember that if your function is equal to any constant, then you're going to be graphing a horizontal line for whatever constant that is along the y-axis. All right, notice in this example, it says graph x equals 5, not f of x equals 5 or y equals 5. This is going to tell you when you have an x value equal to some constant, this is a vertical line. So it's a vertical line at x equals 5. So draw your vertical line here. And that is the graph of x equals 5. And now we're going to give the domain and range. So like the previous one, the horizontal line at y equals 2, our range ended up being 2. But here, your domain are all the possible x values. The only x value in this domain is 5. So just like we wrote the range for the previous one, write it in a set and wherever it is at x equals 5. Now, the range, it's covering the whole entire y-axis. So, it's going to be, again, all real numbers, which in interval notation is negative infinity to infinity. That's it. Alright guys, so for example 4, what we have here is graphing another equation of a line, but this line is in the form that is called standard form, or it may be called general form. So how we're going to do this is like we did the previous equation of a line, where we're going to find the intercepts, the x and the y intercepts. So let's go ahead and find those. So the x-intercept, remember you plug in 0 for your y value and you solve for x. So here what we get is x equals 0. Okay, and then same goes for our y, or similarly, we have a y-intercept, but we plug in 0 for our x value, and we solve for y. And again, we're going to get 0, y equals 0. What this means is we have the origin as our x-intercept and the origin as our y-intercept. Well, this only gives us 1 point for our graph, the origin. We need another point to create a line. So let's just say pick any x value. So say let x equal, and pick a number, doesn't matter what it is. I'm going to say 4. And plug in that value for your x into your equation that you have. So 3 times 4 plus 4y equals 0. So we get, let's see, 4y equals negative 12, and our y ends up equaling negative 3. So there is another point for our graph, 4, negative 3. And we're going to graph that, or plot that on our graph. So 4, negative 3, right there. And then connect these two lines, or connect these 2 points with a straight line. And there we have it. There is our equation of our line. And we're not quite done yet. It also says give the domain and range. Well, just like most of our lines that we've looked at so far, our domain and range have both been all real numbers, or negative infinity to infinity. Okay, here's some things about the slope of a line. That what it is a numerical measurement of steepness, and then it's also known as the rise over run. It's a very good way to remember how to plot the slope of a line whenever you're given the slope in a point. Whenever you have a positive slope, that's what you'll want to do. You rise up and then you run to the right. If it's a negative slope, then I like to call it fall over run. So you go down and then you go to the right. But also about the slope is the change in x over the is this right here. This is known as the change in x, and it's just this right here, x2 minus x1. And this is the change in y, and it's this right here. But what the slope is known as is the change in y over the change in x. And that's what you'll see on this next slide. So how we'll denote slope in our equation is by the letter m. Don't ask me where it comes from. I actually researched this a long time ago whenever I was getting my bachelor's degree, and I couldn't find an answer. But anyway, so the rise, it's known as rise over run, or the change in y over the change in x, right here. And then that just translates to y2 minus y1 over x2 minus x1. Okay? So we've looked at vertical lines and horizontal lines, and then regular equations of lines that actually have a diagonal slope. But if you have a vertical slope, this is known as an undefined slope. The horizontal line, the slope for it is always 0. And then here's some examples on finding the slope of a line through the given points that we have. So we're just going to use our formula right here that we have for our slope and calculate the slopes of the lines for each of these points. Okay, so let's do this. Alright, so change in y over the change in x, so we can say m equals 4 minus negative 6, so plus 6, over negative 2 minus 2. And that equals 10 over negative 4, which reduces to negative 5 over 2. I would suggest you keep these slopes in fraction form because it's easier to plot your equation of your line whenever you have the slope in this form. Okay, let's do the next one. So m equals, I'm going to say 8 minus 8 over negative 3 minus 5. Well, this right here is 0 over negative 8, which is just 0. So this line would be a horizontal line. And then this last one, let's do it. So we have negative 10 minus 10 over 4 minus negative 4, so negative 4 plus 4. So here we have an undefined slope. We have negative 20 over 0. Remember, we can't divide by 0. That is undefined. This means we have a vertical slope, or a vertical line. Okay, so we're done with slopes here. Alright, for this example, we are given the equation of a line and that is in standard form, and we're asked to find the slope. How we're going to do this is, well, how I'm going to show you how to do this first is by just solving for y. And when we solve for y, this is what we're going to get. So I'm going to subtract 2x from both sides, and we end up getting this, negative 2x plus 10. And then divide both sides by negative 5. Okay, when we do this, when we divide by a single number, what we can do is split this up into negative 2x over negative 5 and 10 over negative 5. Well, this gives us the equation. Now, a negative divided by a negative is just like multiplying two negatives. It becomes a positive. So we have 2/5 x minus, because we have a negative here in the denominator, 2. And there's our equation. And now we have this equation of our line in slope-intercept form, mx plus b. Remember, our slope is m, so here it is. Our slope is 2/5. And that's all we need to do for this one. Okay, so I'm going to show you how to graph a line through a point, and it has a certain slope. So first thing you do is plot your point. So negative 2, negative 3. Plot that negative 2, negative 3 right here. And then use the slope to help you when plotting your other point. So what we're going to do is, remember, it's rise over run. So we're going to rise up 4. So 1, 2, 3, 4, and plot that. Well, that's 4. And then run 3. So go over 1, 2, 3. So our next point that we're going to plot is at 1, 1. And there we go. We have two lines. We can draw a straight line through it. And we're done. So here's some more things about slopes. A line with a positive slope rises from left to right. And then, so what this means is, for a positive slope, your equation of your line, it's increasing. It's an increasing function over the whole domain. And then with a line with a negative slope, it falls from left to right. And the function is known as decreasing over its whole domain. A line with a slope of 0 doesn't rise or fall. It's known as the constant. So remember, we studied increasing, decreasing, constant functions. Well, this function is constant over its whole domain. One more thing we're going to look at is known as the average rate of change on a certain interval. And right here we have the formula for average rate of change over an interval from A to B. So this right here is an interval, not necessarily a point. These are two x values right here, A and B. And that's how we're going to find the average rate of change. And you'll notice that the average rate of change is, for an equation of a line anyway, is the same as the slope of the equation. So let's apply that into this problem here. So we have a word problem. It says in 2001, the number of basic cable TV subscribers in the United States was 66.7 million. In 2009, the number was 62.9 million. Assume a linear relationship and find the average rate of change in the number of subscribers per year. Graph as a line segment and interpret the results. Well, I already have it graphed for you here. And what we're going to do, so here's how you plot this. Your time is for your x values, and the number of subscribers in millions goes on your y-axis. And you just plot those 2 points that they give you. So for 2001, it was 66.7, and then for 2009, it was the 62.9. And then just draw a straight line through that. Now you can see that this is a negative slope right here. So we're going to end up with a negative value for our average rate of change. Let's go ahead and calculate it. So remember, average rate of change, it's going to be the change in your y over the change in your x, just like your slope. So I'm going to say 62.9 minus my 66.7 over the years 2009 minus 2001. And then solve that, I get negative 3.8 over 2. Well, no, not 2, 8. And that gives me a decimal of negative 0.475. So the number of what this represents is that the number of basic cable subscribers decreased by an average of this number in millions each year from 2001 to 2009. And then that's all I have for you guys. So you all have a nice night, and I will see you in class.